Assalamu alaikum dear friends and students. In this video, we will discuss the solution of assignment based on chemistry of alcohols. And the first question of the assignment was which of the following molecules may be classified as alcohols. So these five molecules were given and let us discuss which molecule is alcohol. But prior to solving this, let us recall alcohols have a hydroxyl group bonded to a saturated carbon atom. So by this token, we may safely eliminate compound 2 because this hydroxy is not connected to sp3 hybridized carbon, rather it is connected to sp2 hybridized carbon. So as for compound 4, which is also not alcohol because this hydroxy is not connected to sp3 carbon but to sp2 hybridized carbon. Well, now we are left with the option of the compound 1, 3 and 5. Apparently, all may be considered as alcohol because as per definition we discussed the hydroxy must be connected to the carbon which is sp3 in nature. But we must also know that once the carbon which is connected to hydroxy, what about the rest three groups? If the rest three groups are other than carbon and hydrogen, that is they are connected with the carbon is connected with the oxygen or nitrogen, so again that molecule will not be alcohol, or other way around we could say the sp3 hybridized carbon connected to hydroxy and the rest three groups must be connected directly connected to the carbon or hydrogen, then in that case the molecule is called alcohol. So by this token, we may also eliminate compound 1, which is not alcohol, but it is a hemiacetal. And for compound 5, again, this is not an alcohol because although we have the carbon hydroxy, but we have two hydroxy attached to the same carbon. So this is not an alcohol, but it is a diol, which is not considered the alcohol. So by considering these two facts, we are left with the only molecule 3, which is the alcohol, and which is the only answer for this question. Now let us discuss the question 2. It is simply asked to complete the chemical reaction, and that is simply we are asked to draw the product. The first question is the first part of the second question is the treatment of this primary alcohol with the phosphorus tribromide, and obviously this hydroxy will be replaced with the bromine and we will have this halo alkane group. For the question 2, uh, again this hydroxy will be replaced, but this time with the chlorine of this HCl. So it's a conversion of alcohol into the haloalkane. Well, for the part 3, we have sulfuric acid, and this time we will not have the replacement of OH with the sulfonic group. Rather, we will have the elimination and we will have the alkene formed. Because sulfuric acid, although it is an acid as the name suggests, but it is also a dehydrating agent. So once this hydroxy is protonated with the help of sulfuric acid, this hydroxy will become a good leaving group, and uh, rather than the reaction stops at the sulfonic group added here, we will have this beta hydrogen eliminated and a double bond formation between these two carbons to afford this alkene. Well, this is the only part of this question which may be considered difficult because we do not have the alcohol group here, the hydroxy group here, and we are asked to solve this question. So let us recall that this molecule is in tautomeric relationship with this molecule. Both are the tautomers to each other. What did I do? I simply have this hydrogen shown here attached with the oxygen, and as a result this pi bond is shown between the Cn rather than between the CO. So these two molecules are the tautomers, and obviously the first molecule is more existing, but still we have some contribution of this tautomer, and it is this tautomer that will react with this thionyl chloride SOCl2 to afford the chlorine in the replacement of the hydroxy group. So overall, we have this molecule uh, transformed into this molecule with the help of thionyl chloride via the this tautomeric form. Now let us discuss the question number 3. It simply asks to arrange these 6 alcohols into the decreasing order of acidity. Before solving these this question, let us safely eliminate which molecule is not the alcohol. So compound 1, we could simply see that this hydroxy is connected to the sp2 hybridized carbon, so this compound 1 is not alcohol. The compound 5 is also not an alcohol because this hydroxy is connected to sp2 carbon. And remember, for alcohol, the hydroxy must be connected to the sp3 hybridized carbon, that is the saturated carbon. So, so as for the compound 6. So these three molecules, 1, 5, and 6 are not alcohol, so we cannot consider for our answer. Now the answer must be from these three molecules, the compound 2, compound 3, and 4, because all three are alcohols. Well, for a compound to be acidic, it means this hydrogen must be removed as a proton. And here the difference lies between among the substituents. This is fluorine, this is CH3, that is methyl, and this is bromine. So we already know that fluorine is the most electronegative element. So with this fluorine added here, it will pull the electron density towards itself through the inductive effect, and this will lengthen this OH bond, as a result of which this hydrogen will become easy to be removed. So consequently, this fluorine containing alcohol will be the most acidic among these three molecules because of this fluorine inductive fluorine electron withdrawing effect. Now there is a comparison between the C of CH3 and the bromine. We know that bromine is somehow more electronegative than this carbon. So this bromine containing alcohol will be the second acidic, and this methyl containing alcohol will be the third acidic. So this is the decreasing order of acidity. And remember, with the decreasing order of acidity, it means we have to write the most acidic first and the least acidic at the end. If we were asked to arrange these molecules in the increasing order of acidity, the reverse should have been the case. Now let us discuss this question number 4. It says mesylate and tosylate are the two very common leaving groups used in alcohol chemistry. Basically, this question has two parts. First part is to draw the structure of mesylate and tosylate, and the second part is to draw the reaction scheme uh, that converts this butane 1-ol into the pentane nitrile via the intermediacy of mesylate and the intermediacy of tosylate. So let's solve step by step. First, we have to draw the structure of mesylate and tosylate. So this is the structure of mesylate, where we have this methyl and this sulfur, double bonded oxygen, and single bonded oxygen, and there is an anion because this is an anion mesylate with the word with the letters ATE8. We already know that this must be the anion, and this mesylate is abbreviated as OMS, and the full name for the mesylate is methane sulfonate. And remember, if we have this OH here rather than O negative ion, that is if we have this if we when we have the conjugate acid of this mesylate, it will be called the methane sulfonic acid or the mesic acid. So as for the tosylate, you could simply compare the structure of mesylate and tosylate. The only difference lies between this methyl and this para toluene group. We have this phenylene ring between the sulfur and methyl. and it's called tosylate. We have the symbol abbreviation of OTS, and the full name is paratoluene sulfonate. And again, if we have the OH here, we it would be called paratoluene sulfonic acid or the tosic acid. For the part 2, we have to show the conversion of this butane 1-ol into the pentane nitrile, and apparently this reaction is it seems to be quite easy, that this cyanide ion NaCN, where the Cn has a negative charge and Na has a positive charge, this is an ionic compound. This cyanide ion will attack to this alpha carbon, and this hydroxy will leave the system, and we have the substitution of hydroxy with the nitrile group. But this reaction does not happen, and the reason why does this reaction not happen? It's because of the poor leaving group nature of this hydroxyl group that does not allow this reaction to proceed. So what to do? Definitely we need to convert this hydroxy into a good leaving group, and in doing so we have to mesylate this hydroxy group, as mentioned in the first part, in the question, that methylation, mesylate and the tosylate are the good living group used in alcohol chemistry. So the strategy to convert this alcohol to nitrile is to go through the intermediacy of mesylate. First of all, we will have to treat this alcohol with the methyl chloride, the mesyl chloride. It that will generate an intermediate OH. We will be replaced with the OMS, and now OMS is a better living group. Here the cyanide will attack this alpha carbon, and this mesylate anion will remove. As a result, we will get the pentane nitride. Similar scheme also may be followed when we have the tosylation of this alcohol rather than the methylation. In this case, we will have the treatment of alcohol with the tosyl chloride, and which will generate this intermediate, and then the cyanide ion will attack this alpha carbon, and OTS negative ion, that is called tosylate ion, will be removed, and we will have this pentane nitrile. So that's all for the answers of this assignment. I believe that you must have understood the answers, and you also enjoyed solving the assignment. Thank you.